So, I want you to imagine for a second that you're looking out the window of a cross-country flight.
Right, you're cruising at what, 30,000 feet?
Exactly, 30,000 feet. The clouds finally break, and you look down at the agricultural landscape below. And you don't see a random scatter of green and brown.
No, it's never random.
It's not. You see this highly organized patchwork quilt, perfect squares, massive circles, distinct belts of different crops stretching all the way out to the horizon.
It really is a sight when you actually pay attention to it.
It is, and it prompts a really fascinating question. Is there a secret logic to where all those different crops are planted? Like, why is the dairy farm positioned in one specific region while the wheat fields are hundreds of miles away?
From the ground, agricultural distribution might just look like it's dictated purely by, I don't know, local soil quality. Or maybe just a farmer's historical preference.
Right, like their granddad farmed corn, so they farm corn.
Exactly. But when you take that airplane view, you realize you're actually looking at an incredibly complex economic chessboard.
Which brings us to our mission for today's deep dive. We're going to analyze a theoretical framework from our sources that decodes this exact spatial logic.
Yes, we are examining the von Thünen model of agricultural land use.
Such a great name.
It is. It was originally developed in the early 19th century by Johann Heinrich von Thünen. He was a Prussian farmer and estate manager who essentially birthed the field of spatial economics.
The sources we've compiled outline his entire model, and the goal today is to unpack this 19th century framework to reveal the economic geography that still blueprints how and where our food is grown.
It completely shifts your perspective on agriculture.
It really does. It shows that farmers aren't just, planting whatever seed happens to be in the barn.
Far from it. They are highly rational economic actors engaged in strict profit maximization. And they're operating under the heavy constraints of geography.
They are constantly optimizing a complex mathematical equation, right?
Yeah, they are. And this deep dive will connect the specific dots between the cost of the land, the friction of transportation, and the physical shape of the agricultural world you see out that airplane window.
Von Thünen recognized that profitability isn't simply a function of agronomy.
Right. It's not just about having good dirt and sufficient rain.
Yeah. It is dictated by the economic relationship between a specific plot of land and the central market.
The central business district, or the CBD, where the goods are ultimately sold and consumed.
Okay, let's unpack this. Because to grasp the mechanics of this model, we really have to look at the foundational trade-off every agricultural producer faces.
It's a strict balancing act.
Right. On one side of the ledger, you have the capital required to lease or own the land itself. And on the other side, you have the logistical cost of getting the yield from that specific plot of land to the CBD.
That underlying tension is governed by what we call bid-rent theory.
Bid-rent theory.
Yeah. Think about the real estate gradients in any major metropolitan area. Commercial space right in the heart of the downtown core, it commands an astronomical premium.
Obviously. You're paying top dollar for that prime location.
Exactly. But as you move outward into the suburbs and eventually into the rural peripheries, the per-acre cost of land drops exponentially.
It gets way cheaper the further you drive.
Right. Bid-rent theory applies this exact gradient to agriculture. Different land users are essentially bidding against one another, competing for the acreage closest to the central market.
And their ability to pay that rent is dictated entirely by what they are producing.
Precisely. If a producer secures land immediately adjacent to the market, their land rent is going to consume a massive portion of their operating budget.
So to generate any kind of viable margin, they are forced into intensive farming.
They have to. They must substitute capital and labor for land, squeezing maximum yield out of a minimal footprint.
Because they don't have a lot of space.
Yeah.
But the offsetting advantage, however, is that their transportation overhead is practically zero.
Which is the precise inverse of the producer located far from the market center.
Right, out in the rural periphery.
Yeah, the land out there is cheap, which allows for extensive farming. A producer can acquire thousands of acres without over-leveraging themselves.
But the catch is that they are now geographically isolated from the CBD.
Exactly. The capital they saved on the initial land acquisition is constantly drained by the high cost of hauling their output over massive distances.
Von Thünen actually formalized this into a locational rent formula.
He did.
Yeah.
The sources detail that formula, and I mean, it looks like a dense algebraic equation.
It's a bit intimidating at first glance.
It is, but it's basically just calculating yield, subtracting the production costs from the market price, and then, this is the crucial part, subtracting the transport rate multiplied by the distance.
So the main takeaway is that distance literally eats your profit margin.
It absolutely does. And that brings us to the actual commodities being produced. If bid-rent theory establishes the board, the specific agricultural products are the chess pieces.
Deciding which crop goes on which square depends on two specific physical constraints, right? Perishability and transport friction.
Spot on. Looking at perishability first, if you are producing something with a very short shelf life like raw milk or delicate berries, the market dictates your location,
You have to be situated near the CBD to ensure those items arrive in a saleable condition.
especially back then. Before modern refrigeration, a few extra hours in transit meant total inventory loss. You'd just have spoiled milk.
And the second constraint, transport friction, that's tied to the physical weight and bulk of the commodity.
Yes, the physical properties of the harvest dictate the geographic location because heavy, bulky items require significantly more energy to move.
So a rational producer will situate high-friction production closer to the market to minimize those transport variables in the locational rent equation.
Exactly. Perishability and weight are the primary vectors laying the groundwork for von Thünen's spatial layout.
Visualizing this layout is where the theory becomes really tangible. The sources describe it as a massive target laid flat across the landscape.
I love this visual.
Yeah, you have four concentric rings wrapping around a central bullseye, and that bullseye is the market, the CBD, acting as this sort of economic gravity well for all agricultural goods.
Immediately surrounding that central bullseye is Ring 1. According to the model, this innermost circle is dedicated to market gardening and dairy.
And based on the constraints we just established, this is really the only logical configuration.
It is. The peri-urban land next to the center is the most expensive, but the high retail value of fresh produce and dairy justifies the premium.
Furthermore, the perishability factor is absolute. Without rapid, immediate transport to the consumer, the product is literally worthless.
Right, so they occupy Ring 1 out of pure economic necessity.
Moving outward, we encounter Ring 2.
Here's where it gets really interesting.
Because if you ask a modern observer what grows just outside the city limits, they might guess, I don't know, orchards or specialized greenhouse crops.
Sure, that makes sense today. But von Thünen's second ring is forestry.
Timber.
Yes, timber for fuel and building materials.
It seems so counterintuitive to us now.
It does, but you have to look at this through the lens of the 19th century energy economy. Wood was the primary fuel source.
The city required, if we run grains through our two constraints, they actually fit Ring 3 perfectly.
They do. Grains are highly durable. You can harvest wheat, store it in sacks, and it remains stable for months.
Which entirely eliminates the perishability penalty that forces dairy into Ring 1.
Exactly. And regarding transport friction, a cart loaded with grain represents a much higher density of caloric and economic value than a cart loaded with raw timber.
Because they are significantly less perishable and have a much better weight-to-value ratio, field crops can absorb the higher transport rate associated with Ring 3.
The producers are paying lower rents for the land, and the durability of the crop allows them to survive the longer transit time.
Which brings us to the outermost edge of the economic ecosystem, Ring 4, which is dedicated entirely to ranching and livestock.
Analyzing the inputs for ranching, it requires massive expanses of acreage for grazing. Intensive farming simply doesn't work for cattle.
Right. A ranching operation can only achieve profitability by acquiring land where the per-acre cost is at its absolute minimum.
Which places it on the furthest periphery of the model, maximizing the distance from the CBD.
But wait, that creates an immediate paradox within the formula.
It does. If weight and bulk dictate transport friction, and livestock are incredibly heavy.
A producer shouldn't be able to afford the transit costs from the farthest possible ring. The transport variable should just bankrupt them.
Except they bypass the transport variable entirely, because the commodity is self-transporting.
The animals literally walk to market.
They do. By utilizing the animal's own mobility, the rancher effectively zeroes out the heavy transport penalty that usually comes with peripheral land.
They secure the cheapest possible real estate in Ring 4 and eliminate the friction of distance. It's an incredibly elegant solution to the spatial equation.
It is a masterclass in economic logic. However, to construct this clean, concentric model, von Thünen operated like a theoretical physicist.
He treated his landscape like a closed laboratory.
Yes, intentionally isolating specific variables to prove the core economic gravity at play, which required making some massive theoretical assumptions.
The sources highlight several of these, But the most foundational is the assumption of an isotropic plane.
Right. The isotropic plane is a purely theoretical construct. It assumes a landscape that is perfectly flat and featureless in every direction.
No navigable rivers to reduce transport costs, no mountain ranges to increase them, and no variations in soil fertility or microclimates.
Every square kilometer is assumed to be equally accessible and equally productive.
He also assumed an isolated state. In this laboratory, there is only one central market in existence.
The producers operate without any external trade networks, no secondary regional cities, and no competing markets to influence commodity pricing.
It is a closed loop between the flat plane and the single bullseye.
The model also hinges on the assumption of uniform transportation. Von Thünen based his transport rates on a single, fixed technology.
A horse or an ox pulling a wagon over unpaved ground.
Exactly.
But that raises a massive red flag for anyone looking at this today. We do not live on an isotropic plane, and we certainly aren't relying on ox carts.
No, we are not.
We are operating in an era of globalized supply chains, interstate highway systems, and refrigerated cargo. Doesn't the invention of modern logistics completely shatter these concentric rings?
You would definitely think so.
Yeah.
The technological shifts of the last century fundamentally altered the friction of distance.
The deployment of rail networks and later diesel freight collapsed the transport variable in the locational rent formula.
Distance is no longer the insurmountable barrier it was in the 1820s. But the absolute catalyst for disrupting Ring 1 was the perfection of the cool chain.
Refrigerated logistics.
Yes, refrigerated rail cars, trucks, and shipping containers completely decoupled perishability from geography.
A highly delicate crop like strawberries or asparagus no longer has to be cultivated within a few miles of the urban consumer.
Not at all. It can be grown on a different continent, kept in a state of suspended animation within the cool chain, and sold fresh thousands of miles away.
This essentially breaks the isolated state assumption. We are operating in a hyper-globalized agricultural market.
The sources point to specialty farming as the prime example of this. Look at the modern avocado trade.
Avocados are highly perishable and prone to bruising, but they aren't grown in heavily capitalized greenhouses on the periphery of Chicago or London.
Right. They are cultivated in the tropical climates of Mexico or South America and shipped globally.
It demonstrates how comparative advantage now frequently overrides absolute distance.
The environmental advantages of a specific climate, the natural yield multiplier, can easily outweigh the transport penalty.
This is largely because ocean freight and subsidized fossil fuels have pushed the transport rate so low that it no longer dictates the equation the way von Thünen originally modeled.
We also have to factor in the artificial distortion of the market. Modern agricultural geography isn't purely the result of free market locational rent.
It is heavily manipulated by complex government policies, massive agricultural subsidies, and international trade tariffs.
Exactly. A government might subsidize grain production in a region where von Thünen's unadulterated math says it shouldn't exist, simply to guarantee sovereign food security.
Given those massive modern disruptions, the collapse of transport costs, the cool chains, the globalized trade networks, and government intervention, it is a valid question to ask if this 19th century framework has any practical utility left.
Or if it is just a historical artifact of economic geography.
But the consensus from the sources is that it remains remarkably relevant. Spatial economists and geographers still utilize the foundational logic of the model to analyze logistics, land use patterns, and supply chain vulnerabilities.
If we connect this to the bigger picture, the true testament to the model's durability is how it scales.
Let's examine the macro scale, applying the framework to the entire continental United States.
If you treat the U.S. landscape as a massive iteration of the model, the results are actually striking.
Assume for a moment that the densely populated eastern seaboard, the historical megalopolis running from Boston down to Washington, D.C., acts as the central CBD.
And assume the interior of the country functions as our plain.
When you map that out, the agricultural belts of the United States align incredibly well with the model's predictions.
Look at Ring 1, the domain of highly perishable intensive farming.
The U.S. dairy industry has historically been heavily concentrated in the Northeast and the Great Lakes region, Wisconsin, upstate New York, Pennsylvania.
It is clustered directly adjacent to that massive eastern urban corridor.
As you push further west, moving away from the East Coast CBD into the geographic interior, you transition into the massive expanse of the Midwest.
This is the domain of extensive field crops. The Corn Belt and the Wheat Belt dominate this region.
These are the exact non-perishable, highly durable grains that the model explicitly assigns to Ring 3, utilizing the cheaper land to absorb the transport costs back to the coastal population centers.
Keep pushing westward into the furthest reaches of the model, the high plains and the Intermountain West.
Historically, this has been the most arid, least productive, and therefore cheapest land in the country.
And what dominates the agricultural landscape out there? Massive operations for cattle and sheep.
Ring 4. A 19th century equation based on the transport friction of an ox cart successfully blueprints the macrogeography of a modern superpower's agricultural output.
It proves that while the mode of transportation evolves, the underlying economic gravity remains constant.
The tension between the capitalization of land and the logistics of distance is an immutable force.
But the model's utility isn't restricted to continental analysis. It is equally visible when you zoom all the way in to the microscale.
The sources highlight how accurate bid-rent theory remains when analyzing the modern local food movement. Look at community-supported agriculture, or CSAs, and urban farmers markets.
The producers supplying those markets are typically operating on relatively small, highly expensive plots of peri-urban land situated right on the fringe of the city limits.
Those producers are executing the exact strategy dictated by Ring 1. They are paying a severe premium for that land specifically to position themselves adjacent to the consumer base.
Their entire business model relies on guaranteeing extreme freshness and minimizing the transit time from harvest to sale.
They justify the highland rent by commanding premium retail prices for highly perishable niche goods, while simultaneously driving their local transport overhead down to almost zero.
Whether we are analyzing a microfarm maximizing yield on an expensive acre outside of Seattle, or a corporate wheat operation spanning thousands of acres across Kansas, the underlying mechanics of Johann Heinrich von Thünen's model are still actively pulling the strings.
We began this deep dive by looking down at that patchwork quilt of farmland from an airplane window, searching for a unifying logic.
And we found it in a framework built around the agonizingly slow pace of a wagon, the friction of heavy firewood, and the economic elegance of self-transporting livestock.
It acts as the invisible scaffolding of our entire food system.
It is a vital reminder that geography is an economic reality, not just a physical space. The technology overlay has certainly changed.
We substituted the ox for a refrigerated diesel truck and the local town square for a complex, globalized supply web.
But the core tension, the battle between the inherent value of the acreage and the logistical friction of moving mass across a distance, remains a fundamental law shaping the world.
The rules of the spatial equation hold true, even as the variables themselves become more efficient.
Exactly.
Which leaves us with a provocative thought experiment to close on. We've established that the friction of distance and the logistical cost of transportation dictate the map.
The entire agricultural layout expands or contracts based on the difficulty of moving physical goods.
But consider what happens to the von Thünen model if radical emerging technologies completely rewrite those variables.
Imagine a scenario where fully automated solar-powered transport drones reduce the logistical cost of moving goods to literal pennies per mile.
Or perhaps even more disruptively, consider the perfection of hyper-efficient vertical farming.
Right, if we can build heavily capitalized high-yield farms directly inside skyscrapers situated right in the dead center of the CBD.
The requirement for vast tracts of horizontal acreage drops to near zero.
If the transport friction vanishes and the reliance on cheap peripheral land is engineered away,
does the 19th century map finally shatter? Or do those four concentric rings simply stop spreading outward across the plain and instead begin stacking vertically into the sky?
it completely reframes everything we just discussed.
It does. Something for you to ponder the next time you look out that airplane window.